This lesson is a review of our parent functions from Algebra 2. And what we have on both sides of this sheet is basic functions that we are going to make an XY table for. We're going to sketch the basic graph, and we're going to identify the domain and range. And this is going to be a reference sheet for you when we do future lessons with transformations of functions, piecewise functions, and things like that. So be sure that everything you have here on this unit is accurate so that it doesn't give you wrong answers later when you come back and reference it. So this first function we have is the linear function, y equals x. And I'm going to give you some specific x values to plug in. And what I mean by plug in is we want to figure out what y is going to be when x is -2. So imagine you plug -2 in for this x, you would then have y equals -2. If you plug in -1 for the x, you would then have y equals -1, and so forth and so on. So for whatever you plug in for x, y is going to equal the same thing. And sometimes you hear this called the identity function for that reason, that y and x are equal. So then we're going to graph the shape. So a -2 in the x direction means starting at the origin, or 0, 0, you're going to go left 2. And then a y of -2 means now you're going to go down 2, and you're going to have a point right there. And then I'm going to go -1 left, -1 down, 0, 0, right 1, up 1, right 2, up 2. And so you can see that when x's and y's are identical, it gives us this linear graph right here. And the domain and range are both -infinity to positive. And we did domain and range in previous lessons, so you should be good to go with that. Okay, so absolute value function. When you see these bars around something, you're being asked to find the absolute value. So first, let's start with these x values. And if I were to plug -2 in for x, these bars mean what is the absolute value of -2? So as a reminder, absolute value means how far is that number from 0. So imagine you are on a number line, here's 0, and here's -2. How many spaces away from 0 is -2? Well, it's 2 spaces. That is a physical distance, a length or measure, and when we are measuring a physical distance, the answer is positive. So we would say that the absolute value of -2 is equal to 2. So when x is -2, y is +2. So you can see that absolute value is always going to give us a positive answer. So when I plug -1 in for x and take the absolute value, that gives me y equals +1, and then 0, and then 1, and then 2, if you were to plug those in. So this graph looks like, my first point is going to be, so I'm going to come to 0, 0, x -2 goes to the left, and then y +2 goes up, and there's my point. And then my next ordered pair is -1, +1, so left 1, up 1, 0, 0, over 1, up 1, over 2, up 2. So you can see that this portion of the linear or identity function, once it's been reflected over the x-axis, so it's reflected up here because it took all of those negative values and gave us back a positive value in return. And so there will be no negative y values with the absolute value function because your outputs will always be positive. And by outputs, I mean the y values, the x's are considered inputs. And so the domain here is -infinity to +infinity again, but the range is 0 to +infinity. And I'm going to give that 0 a straight bracket because that is an included value in the domain. For the quadratic function, we're going to use these same x values for our xy table. And when I put -2 in for this x, this function means that you're squaring whatever the x value is. So notice that I put I included the negative in parentheses. So negative 2 squared means negative 2 times itself, and a negative times a negative is positive, and 2 times 2 is 4. So when x is negative 2 and I plug it into this function, y equals 4. So I'm going to do that same math for the rest of these x values, and it will give me positive 1, 0, positive 1, 4. And I'm going to graph that. Left 2 up 4, left 1 up 1, 0, 0, right 1 up 1, right 2 up 4. And this, so whereas absolute value had a corner here, a sharp turn, quadratic is a smooth curve. But the domain and range are the same as absolute value. Okay, on the back, we're going to start with the square roots. And the x values that I want to use here are 0, 1, 4, and 9. What's special about these x values is they're all perfect squares. So when I go to plug them in for x, they will give me an integer value when I take the square root. So it just makes pretty points for graphing. So the square root of 0 is 0. When I plug 1 in for x, I have the square root of 1, which is 1. When I plug in 4, I get the square root of 4, which is 2. And when I plug in 9, I have the square root of 9, which is 3. So when x is 9, y equals 3. And then here's what those points look like on the graph. 0, 0, 1, 1, 4, 2, and 9. 9 goes off a little bit, 3. So the domain here, my left boundary is 0, my right boundary is positive infinity, and 0 gets a straight bracket because it's included. And then my range is the bottom to top for the y values. The smallest y value is 0, and the greatest is infinity, and again 0 is included. For my cubic function, I'm going to go back and use these x's, negative 2, negative 1, 0, 1, 2. And this time, when we have an odd power, here's what that means. It means negative 2, 3 negative 2's being multiplied. Negative 2 times itself 3 times. So if you think about this, let's do the 2's first. 2 times 2 is 4, times 2 is 8. But when you multiply the first two negatives, that's going to give you a positive. And when you multiply by negative again, you're going to have negative 8. So when x is negative 2, y equals negative 8. When I plug in negative 1 times itself 3 times, gives me a negative 1. 0 cubed is 0, 1 cubed is 1, 2 cubed is 8. So I'm going to graph those. Starting on my origin, I go left 2 down 8, left 1 down 1, 0, 0, over 1 up 1, over 2 up 8. And there are no corners or edges here. It's a smooth, continuous curve all the way up. And the domain and range are both negative infinity to positive. Now for cube root, I want you to use the following x values: negative 8, negative 1, 0, 1, 8. And the reason I want you to use those is those are perfect cubes, so I will be easily able to take the cube root of them without getting a decimal and still having integer values. So when I put negative 8 in, a cube root of a number means what times itself 3 times will give me negative 8. Well, we just did that the other direction up here. It's negative 2. And in fact, the cubic function x cubed and the cube root function, cube root of x, are inverses of each other. This means that their x and y values are flip-flopped. So that's why -8 cube root is -2, and up here -2 cubed is -8. So really I can just take all these x's and copy them down here. And now I'm going to graph that. So this time I'm going left 8 down 2, left 1 down 1, 0, 0, right 1 up 1, and then 8, and then 2. There's my cube root function. And my last function is a rational function where we have the x in the denominator. When this happens, you create a vertical asymptote because in this situation, x can be any real number that you can think of except for one number, and that is 0. X can never be 0 because you can't divide by 0. We call that undefined. So that's going to create a vertical asymptote right here. And it's going to take all the x values on the x-axis and break this up into two pieces. So 1 over x has two different curves to it. I'm also going to have a horizontal asymptote here because there's no value that I can plug in here that's going to make y equal to 0. Since there's no variable in the numerator, this is always going to be a 1 up here, and I'm always going to be dividing by some other number. There's no mathematical situation that will make 1 divided by something equal 0. The only way you could get 0 by dividing is if you somehow had 0 in the numerator, and that's never going to happen here. So we also have this asymptote because y will never be 0 and the graph will never cross here. So here are the values I want you to use for rational. -2, -1, -1/2, 0, +1/2, +1, and +2. Now when you go to put -2 in for this x right here, you'll have 1 over -2, which is -1/2. When I put in -1, I get -1. When I put in -1/2 for 0, I have a complex fraction. So when you divide by a fraction, you are really going to multiply by the reciprocal. So you change the division to multiplication and flip that denominator. It becomes -2 over 1. And then when you multiply, you get -2. 1 over 0 is undefined. 1 over 1/2 is +2 because, again, you multiply by the reciprocal. And then we have 1 over 1 is 1, and 1 over 2 is 1/2. So I'm going to graph these values. Left 2 down 1/2, left 1 down 1, left 1/2 down 2. This is going to create a C-shaped curve like this that approaches both asymptotes but never crosses. And then we have the positive values over 1/2 up 2, over 1 up 1, and then over 2 up 1/2. And then the domain and range. Oh, I forgot this domain and range. So let's finish this one up here for cube root. Now, because there's two sections on the rational, we'll have two parts of a domain joined with a u. So this is the domain for this left section, -infinity to 0. It breaks here and picks back up after 0, 0 to +infinity. And the same thing with the y's. -infinity to 0, it breaks, picks up after 0, and goes up to +infinity.